Now we define a function which implies that the space is a matrix space. Okay, if you have 2 points p1 which is equals to x1 comma y1 and p2 is equals to x2 comma y2, and the function d of p1 comma p2 which is equals to under root x1 minus x2 whole square plus y1 minus y2 whole square. Now we have to prove that this function makes a matrix space on R. How do you prove that? If this function implies three properties: non-negativity, symmetric, and triangle inequality, then this implies that this function makes a matrix space on R, right? R2, right? This is because this is in R2, right? And this is also in R2. So this function makes in R2 space. Okay, a matrix space. First property is non-negativity. What is non-negativity? If this is the whole square of x1 minus x2, this is always positive. y1 minus y2 whole square of this is always positive. If these two elements are positive, and when you take the sum of these, this is always positive, and the root of this function is always positive. So this function is positive, d of p1 comma p2, which is always greater than equals to 0 because of the square of the functions, right? Now if you take x1 y1 which is equals to x2 y2, so it makes always 0. It makes x1 is equals to x2 and y1 is equals to y2, so it becomes 0. So first property, non-negativity, is possible. So for symmetricness, if dp1 comma p2 which is equals to x1 minus x2 whole square plus y1 minus y2 whole square, if you take x2 minus x1 whole square, this function, this property, and plus y2 minus y1 whole square, there is no change in between this and this. Okay, so it becomes d of p2 comma p1. So this implies that d of p1 is comma p2 is equals to d of p2 comma p1. So this have a symmetric property, right? Now for triangle inequality, how to prove the triangle inequality? It is always triangle inequality, but when you take the plus z1 minus z2 and plus minus z1 minus z2 and take triangle inequality, then it makes triangle inequality possible. Okay, so it makes a matrix space.